dipole moment occurs when a molecule has a partial positive and partial negative on one end of the molecule. Something like this is a good example. This end would be partially positive, and this one would be partially negative. Something like this. Since they have equal strength, neither is more electronegative than the other. There is no dipole moment for something like this. Example that might be a bit different, say, how about water? Does this have a dipole moment? Oxygen is very electronegative as well. These will have partial positive charges, and this one will be partially negative. So the dipole moment will go this way. And this means that this end is positive. So for this one here, and for this one, since they are even, there won't be a dipole moment. And I'll do one more. Carbon dioxide probably is a good one. Is there a dipole moment for this? Well, oxygen is more electronegative than carbon. But is there a dipole moment for this? And the answer is no. Because they're on opposite ends, the geometry causes these two to cancel out. Think of it as a tug of war. You might have two people that are pulling, but if they're of the same strength, then what is the net effect? Nothing. If it was something, say if it was something different, say, I'm just putting X here, don't worry about what it is, just suppose, just don't worry about it. Let's just suppose X was just neutral. What would be going on here? Well, there would probably be a dipole moment going this way, because chlorine would be pulling the electrons toward it, and it's stronger than hydrogen. If it were like this, this would be another case where there be no dipole moment. Because even if chlorine, just assume that chlorine is more electronegative than X. Get the same kind of situation. Where the net effect will be zero. Imagine a three-way tug of war. If they're all the same strength, then this won't go anywhere. But in this example over here, if you had two regular people and then one roided out guy, then the net effect of this be this way. Which probably needs like a six-pack. Massive chest. And big quads. But yeah, a roided out guy would win. He would pull everything this way. So that's the idea of how to determine whether there's a dipole moment or not. Just look at where the bonds are. Look and see if there's something that is more electronegative, and then look at the geometry. If something is more electronegative and there are two the same, then they'll cancel each other out as long as the geometry is even. So in the case of carbon dioxide, since they are both in a line, they both have equal strength. The net effect is nothing. In this example, chlorine is stronger than these two hydrogens, so it will pull the electrons toward itself. But in this example, since all the chlorines are even, the geometry causes the forces to be evened out, so there's no dipole moment. And a dipole moment, I guess the technical definition, a dipole moment is when, so this is how they would do it. They would have an electric field, and they would have all the molecules here. When they would turn this on, all of the molecules that had partial and negative charges, they would align themselves in this field. So if I had water and I put it in an electric field, all of the oxygens would be pointing this way and the hydrogens would be pointing this way, like this. All of the water molecules would align themselves in this general direction, and that is what is called the dipole moment.